Mwalolesha my electrical schematics mwala monati they're essentially identical. Okay, so we just focus on this part. Ukumuluta parifidi kwa feni live and ya supply yuku after 4A5 and 4BE5, so it's really not much to stress about. Okay, but ingatuaponena ko punch pa no like so. Twalasangati muri position designation 4AE2. We'll just think of this as the earth leakage protection device 4AE2, similar to 4BE2. So these two positions essentially just earth leakage protection. Then ngatwaisa isapari 4AE3 na 4AE4. These are just thermal overload positions. Now, ikwetama thermal overloads yabidi, in the sense that each vibrator has got two motors. Okay, so each motor is going to have its own separate thermal overload. The same thing applies to vibrator number 2. Na ikweta 4BE3 na 4BE4. Okay, then thereafter tuakwata na selector switch. Now you can either select vibrator number 1, okay, which is on the left side, or select vibrator number 2, which is on the right side, but you can't run both vibrators at the same time. Okay, then thereafter tuakwate ivalevati Part010 switch. Now Part010 switch ni limit switch fe yakwebati as the crusher, or rather as the vibrators are feeding the material into the crusher bore, right? And then that crusher is of course putting that, or rather is channeling those crushed materials into like a bin beneath the crusher. Okay, and then depending on the level of the material mudi bin mudia, it's going to activate more like a limit switch kumolu kudia when the bin is full, and that's what we're going to be calling the Part010 switch. So when the bin is full, where the crusher is basically channeling all these crushed materials, the Part010 switch is going to be actuated, and then it's going to open this position. Okay, so the normal position is closed, and then when the Part010 switch is actuated, it opens the path leading to the control yama vibrator coils, okay, power contactor coils, by way of 4AC1 or 4BC1. So the Part010 switch essentially just de-energizes these power contactors, or it prevents you from running the vibrators when there's too much material in the crusher bins. Okay, so that's the Part010 switch. Then after the Part010 switch, tuakwata na ibalela ndati motor number 1 isolator kwa bana motor number 2 isolator. Okay, which is to say that I am a motor abiri na kwata ama isolators yabiri. Okay, it's going to look something like this. If we number, our key focus is just on this. Tuamono kweba tiumu, the same jazz. Okay, this section is just talking about protection, and then this is just talking about selection. The Part010 switch is also talking about protection, and then we can also argue to say that the isolators, okay, the isolators are also talking, or rather they are related with the aspect of protection. Okay, and then thereafter the system, the vibrator stop, and then the remote stop, that is, and then the vibrator local stop, and then thereafter there's the vibrator control interlock 282, and then there's the remote start, the local start, the ceiling contact 4AC1 related to 4AC1 power contactor, and then 481 is just a vibrator number 1 fault trip relay. Okay, and of course we've got the 4 trip indication, and then the vibrator number 1 running indication, and then the configuration of this is essentially the same with this other one. So what we have said about vibrator number 1 also holds true for vibrator number 2. we're going to insert a function, or rather insert an object, but in this particular instance we're going to insert a functional block, and then the language is going to be ladder, and then this is going to be, this is what we're going to call vibrator control logic. Okay, that's what we're going to call this. And then of course we're going to ensure that and that multiple instance capability is marked in. And then of course we're going to do what do we do? Okay, so this is going to have multiple instance capability, and then we're going to insert a function. Okay, we're going to insert a function, insert object, insert function. Then we're going to call this as vibrator control. Okay, and then having called this as vibrator control, we're going to open the OB1. Okay, and then we're going to insert a network, and then we're going to call function 9 in this OB1. Okay, like so. And then we're just going to save this and then close this. The reason why we have done this, the reason why we're calling function 9 in OB1, because the instances of this vibrator control functional block, this FP1, we're going to call 2 instances of this functional block in function 9. And that because function 9 is already called in OB1, then that basically means our functional block is going to be processed. So we can just open this object. Just going to open this object, and then before we do anything else, we're going to create the symbolic names. Okay, and to start with, okay, so where did we end? We need to identify protection inputs. So the protection inputs had memory bit addressing in the range of 2021. Okay, so we're going to say insert symbol, and the first symbol is going to be 4AE2, and then this is going to be vibrator 1 at leakage protection. We move on to the thermal overloads. Okay, so we get to this point, insert, because we're talking about protection still. So we go like 4AE3, and then 4AE4. Okay, so these will be vibrator 1, motor 1, thermal overload. Okay, and then for the other one would have something like vibrator 1, motor 2, thermal overload. Okay, which takes care of these two, right? And then thereafter, these are protection inputs. So 4AE3, and then there's 4AE4 protection inputs. Okay, so we've taken care of 4AE2, 4AE3, 4AE4. 4AD1 is a resultant condition. Okay, so this is vibrator number 1 fault trip. So basically it's an output coil. So let's go to where we have the okay, let's limit ourselves to the inputs first. Okay, so we've done the protection inputs, and then the selector switch, the 3-position selector switch. Okay, as an ordinary input. So we go to where the inputs are, in this position right about there, insert symbol. So we're going to say come on, vibrator 1, select. Okay, set symbol again. We have vibrator 2, select. Okay, so we've got vibrator number 1 select, vibrator number 2 select, maybe. So let's see, vibrator number, oh come on, vibrator number 1 select, vibrator number 2 select. So this takes care of this position. And then the powder switch is also a protection input. Okay, so we go to the protection addresses, set symbol. So we go like vibrator powder switch. Okay, so let's say vibrator 1 powder switch. Okay, so we have vibrator number 1, vibrator number 1 powder switch. Okay, so which takes care of the powder switch as a protection input. Okay, and then we can also think of the motor isolators, like motor number 1 isolator and motor number 2 isolator as protection. Okay, so what do we have? We come here, so we have vibrator 1 motor 1 isolator. Okay, so we have vibrator number 1 motor, come on, motor number 1 isolator, right? And then insert symbol. So the isolator I'm talking about is this one, motor 1 number 1 isolator, motor number 1 isolator, motor number 2 isolator. So again, copy this, paste there, vibrator number 1 motor 2, come on, motor 2 isolator. Okay, so which is IS. So we're going to copy this, paste there, vibrator number 1 motor 2 isolator, right? So that takes care of this position right there as protection inputs. Okay, and then thereafter we've got the remote stop and then the local stop. Okay, so these are normal inputs. So we go right about here. So we say vibrator 1, vibrator 1 local stop. Do I need a capital L? Local stop. Okay, insert symbol, copy this, paste there, vibrator 1 remote stop. Okay, so we've taken care of the local remote stop, then the local stop. The local stop is actually 4AB7. Okay, 4AB7. Do we forgo this whole designation because we don't really have the equivalent of this? Okay, so this is 4AB7. So do we have 4AB8? I wonder. I don't really think we do. So this is 4AB7. Okay, so what I'm thinking is this is 4AB7, right? So maybe if we did this, okay, let's take this, paste in the comment section. Okay, and then we'll go like 4AB7-001. Okay, then cut this, paste there, then for AB7 002. Okay, so basically all I'm saying is for AB7 001 is the vibrator 1, vibrator 1 local stop, and then 002 is vibrator 1 remote stop. Okay, because we don't have the designation. Stop, local stop is for AB7, but we don't have anything for remote, so which is why I've resolved to just do it like this. So this takes care of this, takes care of that. And then 282 has already been defined as the vibrator control interlock. Okay, and then thereafter we have remote start and then the local start as 4AC1. So we do the same thing. Okay, so as normal inputs, go, insert symbol. This is for what? This no. The start, the local start, and then the remote start. They have nothing associated with them. So what do we do with this? What do we do with you? Okay. What do we do? So let's see, vibrator 1. Okay, because we really don't have the designation, so let me borrow this. Okay, let me borrow this, insert symbol. Okay, I'm going to borrow this, I'm going to paste there, I'm going to borrow this one here, I'm going to paste there, and then I'm going to call this as 4AB8. Okay, 4AB8, like so. And then of course 1 will be vibrator 1 local start. Okay, and then vibrator 1 remote start. Okay, now I know we don't have these 4AB8 001 002 in this, because as you can see here, there's nothing. I'm just improvising. Okay, I'm just improvising. So that's what we've done with this one, that's what we've done with that one. So that's as far as the normal inputs go. Okay, this is all the inputs we have. We've done the protection inputs, and then we've done the normal inputs, and then now we deal with the outputs, right? With the outputs, we've got the vibrator 1 paddle switch operated. So as an output, the output addresses ended here. Okay, such symbol. So vibrator 1 paddle switch operated. Okay, so we have vibrator number 1 paddle switch operated. Okay, so V1 as vibrator number 1, P paddle switch, paddle SW switch O operated. You can do it whichever way you want, but this makes sense for me. So this takes care of this. Okay, but it's indication. Okay, that's what this is. Paddle switch operated. Okay, maybe IND for indication. Okay, I know it looks ridiculous, but that's as far as I can think of how to label this. So vibrator 1, I'm calling it vibrator 1 because even vibrator 2 has got a paddle switch. Okay, it's got this one here. So often that vibrator 1 paddle switch operated indication, IND as indication. Okay, and then this takes care of this. Then to quarter for AC1 as vibrator number 1 on. So this is an output call. So we're going to insert symbol. This is going to be 4AC1. Okay, so this is what vibrator number 1 on, okay, which is 4AC1. And then thereafter we are talking about vibrator number 1 fault strip indication, designation 4AD1. Okay, we just incorporating this for convenience, but we could even do away with this if we wanted. So as an output coil, it's in this position, and then this is what? This is 481. This is vibrator number 1 fault strip. Vibrator number 1. Vibrator number 1 fault strip, which is this 481, right? And then the indication. Okay, so we come here again, 4AH1. Okay, so vibrator number 1 fault strip indication. Okay, as an output coil. Good, so we've done for H1, and then the last one is vibrator number 1 running. So 4AH2. Okay, so we come here, so we have 4AH2. Okay, so this is vibrator number 1 running. No, anyway, I'll cut it. These are signs of exhaustion now. Okay, so vibrator number 1 running. So we've covered this part here. Okay, so basically we've covered all the inputs related to vibrator number 1. Okay, so we can do the same thing with vibrator number 2.
A few minutes later.
So basically that does it for this symbolic name business. Okay, so we can close this now. Hopefully we've covered every other thing we could think of. Now, just to remind ourselves, this interface we're in, okay, let me just open this again. We're going to open FB1, the one we're calling at vibrator control logic. This we're going to open. Okay, this we're going to open. We're just going to look at, well, we won't even bother with with vibrator number 2, but our core focus will be just one of these vibrators, because Gamwamona, their operation is essentially the same thing. Okay, and then we're going to do something that may be a little bit confusing. Remember, when we just started out, the need to have control over the protection inputs. Okay, in the sense that we needed to be made aware of any transition in the protection inputs. It's not an actual operational state that has caused the input to change its state. Then the system gets into this faulty state, machine, everything normalizes, and it gives you a pain just to try to resolve that issue. And when we did that, we were latching all the input conditions. Okay, we are just purely latching them. So because of the way the protection inputs were being validated, we can modify this to, we won't even bother with latching these protection states mukatium. Why? Because when these signals were being passed to the PLC and then the inputs were being validated, the protection inputs were being validated, just there to normalize the system, we needed to reset those inputs. And it's only their state which are being used now, muri logic, yes. For you to understand what I'm talking about, look at that section where we are talking about input validation. Okay, having said that, we identify the protection inputs and the way they're used, the same reasoning as before. So we have 3 of these, and then on the input side of things, okay, we come to where in the interface you left click on the in section, and then on the right section where it says contents of environment or interface in. Okay, first mbana earth leakage. Okay, we don't have access to use. Okay, so we can just say earth leakage in the first instance, right? It's a boolean data type. Okay, because that's what this is. It's just earth leakage, and then motor 1 thermal overload, motor 2 thermal overload. So in the next instance we have motor 1 thermal overload. Okay, I don't know whether we leave it like this. Do we even, anyway, I don't think I need this section. So do we have comments? Okay, maybe we won't need to see a lot of this, but need for us to see the comments. Okay, like so. So if I just say M1, can I just say motor 1 overload? Okay, and then maybe this one is just EL. In the comments we'll go like earth leakage, okay, like so. And then this is going to be comment motor 1 thermal overload. Okay, which is this one here. Then motor 2 thermal overload. Okay, so maybe let me just copy this, paste there. No. Then of course this is motor 2 thermal overload. Okay, so we're talking about this one here, and then okay, we've gotten the earth leakage thermal overload, and then of course we're talking about what are you called, vibrator number 1 fault strip. Okay, but I also need it to have a fault strip indication. Okay, so we'll just focus on this part first. Okay, so at the end of this we have fault strip. Okay, so what I'm going to do is I'm going to come to where it says static. Okay, I'm going to say static. I like saying 001, but in actual fact you can even say static 1. Okay, it's a boolean. Okay, so in this path where it says earth leakage, I'm going to get this here. So we're in this position, earth leakage coupled to the 2 thermal overloads. Okay, so we're going to have motor 1 thermal overload, and then we've got motor 2 thermal overload. Then we're going to pass that state to an output coil. Okay, which will, in this case, I'm just going to use the static. Okay, I'm going to say static, and then what I've done is the result of this. Okay, the result of this is being passed to this. I'm not really calling it 481. In this position I'm going to use static. Okay, now because this is basically just protection related, I'm going to negate this. Okay, I'm going to negate this. I'm going to negate this. Yeah, come on. I'm going to negate this and then pass the result to static, okay, to static 0, 1. I'm going to set a network, and then of course, what do we do? Normally open contact with static, okay, and then I'm going to pass that state to what is being referred to as vibrator number 1 fourth trip, okay. So on the output side of things, okay, vibrator number 1 fourth trip, in this particular case, we're just going to say vibrator fourth, okay. Can we get away with vibrator fourth? Okay, maybe. Okay, so this we're going to call vibrator fourth, okay. So that's what we're going to call that. And this one, ladies and gentlemen, is going to be the general representation of this, okay. We don't care whether it's vibrator number 1 or vibrator number 2. We're just going to say vibrator fourth, okay, which is this one here. And then of course there's also the indication, okay. So this one we can just get away with just doing this, and then as an output we can do that, and then this is IND, okay. This is IND. Then this is indication, okay. So this one here will come there, okay. So this takes care of the fourth strip indication. So we've taken care of 4AD1, and then we've taken care of 4AH1, okay. And then thereafter, what do we have? 4AC1 is not yet taken care of, so okay. So now, because we know this section is all about protection, okay, this section is all about protection. So we have another network, insert network. In this network, we're talking about the first thing is protection, right? So this is static, like so. So this whole thing, the state of this is passed on to a general variable which we are calling static. Now the reason I've chosen to use static in this, because if I'd chosen to define this particular one as vibrator fourth or vibrator fourth indication, I would have had to define it as an in-out variable, in which case it shows up on the input side and not on the output side. So which is why I've chosen to use static, okay, because these won't even show up on the interface of the final block call, okay. They'll just be internally used. So this is why I'm doing it like this. So vibrator fourth as a representation of 4AD1 or 4BD1, and then of course the VFLT indication as a representation of the fourth trip indication, okay. And then in this state, I'm saying the status of all of these is passed to static 001, and thereafter we've got the selection, okay. So this one will be vibrator select as an input. On the input side of things, we can say vibrator VS, okay. In this case we'll say vibrator select, okay. You can either choose vibrator number 1 select or vibrator number 2 select. It really doesn't matter, okay. This we're going to paste there as vibrator select. So we're past this position, And then the other thing is the powder switch is also part of protection, like we previously said, and then the isolators. So let's see. Static can also accommodate those three aspects. Okay, so we're saying on the input side of things, okay, we can also say the vibrator select this and that. Vibrator select, I need to new declaration, and then we're saying powder switch, powder switch. Okay, what did we do with our symbolic table? What did we call the powder switch? Powder switch. No. Okay, powder switch operated indication as an output, but on the protection side of things, let's see U. Powder switch. Okay, maybe I need to put a dash there and the dash there, so it's PSW for powder switch. Okay, so PSW, which is fine. And then the other thing we're taking care of the powder switch, the isolators. Okay, so let's see, insert new declaration, another new declaration. Okay, so we've got motor 1 isolator. Okay, so and then this is motor 2 isolator. Okay, these are both Boolean. You can't see it, but they're Boolean declarations. Okay, so this one here is the powder switch, and then this one here is motor 1 isolator. Okay, this one here is motor 2 isolator, right? So these isolators, ladies and gentlemen, I'm going to just pick powder switch there, the isolator 1 there, isolator 2 there. Okay, because we said we're going to treat the powder switch as being part of the protection, the isolators are also as being part of protection, which you can easily see from the addressing. Okay, because if you look at the protection addresses, you find that the powder switch has got memory bit 23.1, which is the range of addressing for the protection inputs. Okay, and so even the isolators, it's the same thing. The range of addressing is those we chose for the protection inputs, which is why, in as far as the vibrator is concerned, these are part of its protection inputs. So that's why I've done them like this. Okay, so that now all these protection elements are actually part of this variable. Okay, what else do we need? The other thing we need, okay, I know what you're thinking. What you're thinking is these isolators and the powder switch are not part of the original control of the fault strip. Okay, but in a way you could also think of these as being part of the protection aspect. Imagine if for some reason this vibrator was running and someone opens the isolator. Okay, so this would clearly trip the vibrator. Okay, it would clearly trip the vibrator because of this position 41. It's going to open, if this is energized, it's going to open 4DC1, 480one. It's going to open here. Okay, so this is never supposed to be energized. Okay, so internally implemented in the PLC, we're going to do it like this. It looks different, but it will operate in exactly the same way. Okay, so there we go. So static protection part, protection. So we've dealt with all the protection elements. We've picked essentially all the protection aspects in this section which were responsible for AD1. Okay, and then we've also added the isolators as well as the powder switch. Okay, so the only other thing we need now is this. Okay, after the protection, okay, then you select the vibrator select in this path. Okay, protect, vibrator select. So the only thing now is the remote stop. Okay, so remote stop externally, I'm not so sure, I've forgotten the normal state in factory IO, but I should think it's normally closed externally, momentary action. So internally to be just normally open. So this will be as an input. Okay, as an input, it's going to be what? It's going to be local stop. Okay, so vibrator local stop. Okay, so this is going to be vibrator local stop, and then the other one will be vibrator remote stop. So get this comment, paste it there, and remote. Okay, remote stop. So we're there. So another one normally open. So vibrator local stop, then vibrator remote stop. So we've come all the way there, and then the vibrator control interlock. Okay, so this is vibrator interlock. Okay, so this is going to be vibrator control interlock. So this is a vibrator control interlock, VINT, and then this is normally open. Okay, so we have it there. It's vibrator control interlock. Then of course we've got the parallel branch in this position. Okay, so in that position, what do we need? We've got what do we have? Normally open. We need a parallel branch like so, and then we need an output coil. Okay, so we need the local start, remote start. Okay, so here we have vibrator local start. Okay, vibrator local start STRT, and then vibrator remote start. STRT is just start. Okay, so the first one will be vibrator local start. Then this one is vibrator remote start. Okay, So now these two are basically just across from each other. It's a parallel configuration, okay? Vibrator local start, vibrator remote start, like this. And then we need an output coil, okay? I'll go back to static. Then I'll define another static variable, okay? Static 002. Again, it can be static 02, static 2, whatever you want, you can write, okay? So static 2 will be the placeholder for this, okay? Then I'm going to insert a network, and then normally open. I'm going to get this variable here, paste it there, then get an output coil. This is what? Vibrator number 1 on. So we go to the output side of things. So we just say vibrator on, okay? We don't care which vibrator it is, but this is just vibrator control, okay? So this vibrator on will be this one here, okay? So now we've taken care of the allocation for 4AC1, okay? And then for 4AC1, what else do we need? We did 4-trip indication. We've done the 4-trip indication, and then 4-trip indication, vibrator running, okay? So this one here, in as much as I think it's really not necessary, vibrator on indication. Oh. Vibrator on indication, okay, like that. So we get this, create a parallel branch like so of an output coil, assign the address. So vibrator running indication. It says vibrator running indication. What did we have? Maybe running, vibrator running indication, okay? Vibrator running indication. So we have taken care of this, and then this, okay? I know this is 4AC1 is responsible for vibrator number 1 running indication, but the other way is this, okay? The other way we can do it is this. We can do this, okay? On the input side of things, okay? On the input side of things, we can say vibrator feedback, okay? So vibrator, come on, vibrator power contactor feedback as an input, right? So that internally we have this right here. Get this one as vibrator feedback, paste it right there, and then get this output coil, paste it there, and then we're good to go, okay? So that the indication that the vibrator is running is given by a feedback condition, okay? So that's why we've done it like this. I'm sure now, I think this pretty much takes care of whatever this is, okay? Except the only thing we haven't done is the Part010 switch, okay? So for the Part010 switch, operated, the Part010 switch is wired, okay? Part010 switch has an indication, okay? Insert network. So internally we're using them as normally closed, because externally to the PLC they are wired through normally closed contacts, and then after input validation they are negated. Okay, so ideally it would be like something like normally closed, and then we negate. Okay, powder switch, we get this one here, and then no negate, and then powder switch operated, this indicator lamp. Okay, and then options, symbol table, what did we say as an output? Powder switch, no, came right after. Okay, so powder switch operated indicator. Okay, so what we need is this one here. Okay, and then on the output side of things, out, powder switch operated indication. Okay, maybe this thing here, underscore. Okay, so powder switch operated indication. Okay, and then we get this one here, paste it right there. Okay, so we've also taken care of the powder switch operated. Okay, yes please. When we come to function 9, okay, when we come to function 9, view overviews, then to function blocks, function vibrator control logic, we need to call this, and then these we're going to call db1. Okay, because I know, yes, I need to generate this, and then of course this might as well be vibrator 1. Okay, and then when we call another instance of this, okay, so this will be db2 data block, yes, and then this is going to be vibrator 2. Okay, so this does it. And then when it comes to assigning the addresses, okay, so what do we have here? So earth leakage for the first vibrator. Okay, so this is basically just vibrator 1. Okay, so earth leakage, we're talking about 4AE2. Okay, so we're talking about 4AE2, vibrator 1 earth leakage, then we also talk about 4AE3, 4AE4. Okay, so 4AE, talking about 4AE3, and then we're talking about 4AE4. Okay, and then right after that we're talking about the powder switch. So vibrator 1 powder switch, vibrator 1 powder switch. Okay, vibrator number 1 powder switch. Okay, so the protection input takes care of this. Okay, isolator. Okay, so motor 1, is it vibrator 1 motor 1 isolator? Okay, so vibrator 1 motor 1 isolator, and then vibrator 1 motor 2 isolator. Okay, vibrator 1 motor 2 isolator, and then vibrator local stop. Okay, vibrator select. Okay, so this is vibrator 1 select. So vibrator number 1 select, and then vibrator 1 remote stop. Okay, vibrator 1 vibrator 1 local stop. Vibrator 1 local stop. Let's say what's that thing? Vibrator 1 local stop. It was 4AB7 something with a 001 something. So this one, so vibrator 1 local stop. Okay, and then vibrator 1 remote stop. Vibrator 1 remote stop should be this one here. Then vibrator control interlock was 282. Okay, so 282 vibrator control interlock. And then what else do we need? Vibrator local start. So vibrator 1, that was AB8 maybe, AB8 1 and 2. So AB8 local start, then I think the other one was the same address but with a 2 attached. Okay, with the 2 attached, I think. So vibrator 1 remote start, and then vibrator feedback. Okay, because we really haven't assigned the vibrator feedback, so maybe in options symbol table as a feedback, does it qualify as a protection or normal input? Maybe just normal input. So on the addresses right about here. Okay, right about here. So we have vibrator 1 feedback. Okay, so we have vibrator number 1 power contactor, power contactor feedback. Okay, and then of course we know we're going to need the same thing, but this time for vibrator number 2 power contactor feedback, we're going to need another thing like that. Okay, for reasons explained earlier. Okay, so this is going to be vibrator number 1 feedback. Okay, that's taken care of like that. And then vibrator fault is clearly we're just talking about 481. Okay, so 481, and then for indication we're talking about 4AH1. This is 4AH1, and then vibrator running we're talking about 4AH2. Okay, this is 4AH2, and then which is this one now? Vibrator on. No, this one here is the indication. Okay, vibrator on is 4AC1. Okay, 4AC1 was vibrator on. Okay, and then part switch operated indication. Okay, so I don't know, vibrator 1 part switch operated. Can we go down here? Vibrator 1 part switch operated indication. It's this one here. Vibrator number 1 part switch operated indication. So basically this takes care of the first vibrator. Okay, then the second vibrator is basically the same thing. Okay, so we'll be talking about earth leakage. So 4BE what? 4BE2, and then we're talking about 4BE3, 4BE4. So 4BE3 and then 4BE4. Okay, then the powder switch, that's vibrator 2 powder switch, which is this one here, and then motor 1. Okay, so this is vibrator 1, vibrator 2 actually, vibrator 2, motor 1 isolator. So in this vibrator 2, motor 2 isolator. Okay, then select, vibrator select. Okay, vibrator select, so vibrator 2 select. Okay, and then vibrator local stop, so vibrator 2 local, these were A, B, 4 what, 4B is 08 or something. So this is local stop, vibrator 2 local stop, 4BB7001, and then the same address but with a 2 at the end. Okay, with a 2 at the end. And then vibrator control interlock is still 282. Okay, nothing has changed with that one. Local start, remote start. This is the 4 vibrator 2. Come on. Local start is 4BB8001. Local start. And then this one here. Without me, the exception is just the 2 at the end. Feedback, so this is vibrator 2 if I'm not forgetful. Okay. Come on, what is the other one? Vibrator 2, V2FB. How come V2? Vibrator 2 feedback. Okay, so what are we not getting? Vibrator 2 feedback. You're the one who made the mistake. We need to correct this. So no more inputs. It's vibrator 2, and then we might as well copy this because we don't want any more drama. Okay, and then on this other side, on the output side of things, this is what? This is a vibrator 4, so we're talking about 4BD1 in this arrangement. Okay, and then indication for BH1. Okay, for 4BH1, V on 4BC1, 4BC1 as the vibrator on, the indication is 4VH2. Okay, that's 4VH2. Part of switch operated indication, there's vibrator 2. Oh, come on. Vibrator 2 part of switch operated indication. So vibrator 2 part of switch operated indication. I think that's pretty much it. Takes care of everything. All we need to do is save, and we're done.